motion of the animal we get is in the inverse direction, which is not correct. So I just thought of like leaving a gear train there so that it will move in the correct direction when it is pushed. So this was one thing. And I tried it making this rough model of like so that when I move it, so it shows it replicates the jerk of the fish in the
Yeah.
direction. So this were the ideas.
Fine.
Out of this, I would like to focus on hen because it can be made very cartoonish, and child like goat, dogs, and these are the one of the most seen domestic animals. So
Okay.
I think this was really interesting.
Good. Good. Good.
So basically, what is going on here is this is a single wheel, and there is a paddle, and a kid can stand here, and the wheel will be in between the legs, and he'll hold the handle, and he'll just jump. So kids like to jump up and down, so they'll just jump, and it will guide, and it will roll, and they have to balance and move around. So when the speed like gets less, then they'll just jump and jump. While jumping, they'll get momentum, and obviously there will be a bow inside, and it will like move like that, and it will have a spring. It pulls like away while coming up, and while pushing down, it touches the gear, and it again moves. So there will be gear inside, and it will just work like this, and obviously there will be a cover and handle. And so this is I am basically using the centrifugal force to stable. So that spinner, I took the inspiration from spinner. So what is happening here is so there is a handle and a straight bar, and it has like thin like 2D thin contact surface. It will hold to the ground. It won't rotate, and there is a heavy disc inside, and there is a cover on the disc. So I'm using the here also the kid have to jump up and down. So the vertical movement, it converts into the rotational movement. So sir, I'm taking the movement inspiration from the press drill. In bamboo studio, they are using this press drill. So there will be a ratchet mechanism. So while pressing down, it will rotate in one direction only. While going up, the ratchet will make it free. So sir, I have done this POC for proving the mechanism that like basically it will be on the ground only. When the disc gets momentum, it will stand on its own. So this works. I can show that it will stand.
Okay. Can you show that?
Yes. So basically, this is the this is the cover. So this should be stable, and this should move inside. Basically, it will stand like this. This will be the stable plate where the kid will stand, and inside the heavy disc will move. So
But how it will move?
sir, this disc will be connected to the ratchet and axial movement mechanism. So like this. So this disc will be connected to this thread system, and the cover plate will be connected to this jaw. So while we push it down, so it rotates in one direction, and ratchet will make it free while going up. So
More
it's
complex.
sir, it's actually a simple mechanism they use in the hand press drill to
That is
drill.
right. That's right. But here actually your weight is on
Yeah,
the,
so it should be robust.
issue is
So actually it's little difficult, but we can make it, then it's good to. So So basically my intention was like my brief was to expose kids to have their physical balance, develop their physical balance and reflex action while playing.
No, it's
And there are some others like this the like this will have eccentric wheel, and while paddling it will give that unstable movement the bull rider they have.
yeah.
And so this is another one, like there will be swing. While swinging, the swing uh, takes rest at the chain here. After getting one particular movement, that will just the holding point just moves up with the centrifugal force and rests here. Then it by gravity it pulls down to the bottom point. So this chain will be connected to the wheels. While swinging, there will be like a target that will, and this whole thing will move with this chain drive. So there will be like target to will cover more distance like that. Mm. This is another one, like kids like to jump and rocking mechanism. So they can sit in the chair and they can just do the rocking action. Here yeah. So here what happens, this chair like 4 or 5 chair connected to a big disc, and that is mounted in the ground. And while rocking mechanism, this end connects to the belt. So while going backward, they pulls this. So here the crank will work, and here will be a cross belt. So this gives a rotational movement, and while while coming forward, this covers the distance. Then the pulls and comes forward. So depending on the speed of rocking, the whole disc will move. So here 2 or 3 or 5 kids like climb on, and they'll work accordingly. So another one is like just mimicking the rowing mechanism. So just having the rowing thing, rowing movement, they'll go forward. Here we can work with cam, or we can crank, or we can work with gear mechanism. And so this is like paddling only. So here what happens, while paddling the scooter moves lateral, like sideways, it doesn't go front. So it gives a challenge to have the balance. And I was trying to put a spear inside, so there will be one contact point, so it gives a little challenge. So and now we have to take the safety measurements.
That's true. So all those things must be really designed in such a way that
That should be safe.
they should be
Yeah.
safe. And it will require research.
Yes, sir.
When we went to the playground, we saw that there was this kid, we were sitting on the merry-go-round, and he's like, I'll push it for you. So they are very enthusiastic about helping others to, also play. So I was thinking this could be like an installation, that this is a ride-on. So this won't be this big actually.
Yeah.
The scale is not that
That's okay.
Yeah. So the person just sits on this, and there is another kid who like kind of, this has to rotate completely, the mechanism is not fully working right now. But it has to go round and round. So this will keep moving ahead and backward and ahead and backward. And another thing was like all these joints could be hinged. So like if I have just a small fixed thing, so this will just move in 2 directions like that. So while this moves, the leg and the hand and everything will move simultaneously along with it.
Yeah.
So that was one of the ideas. Then this was another idea. I have not made a model for this. So this is like a turtle, like a upside down turtle. So it's just like a bowl kind of a thing in which you have a lap joint. So it just goes round and round and round. It's a free rotation, so you can just keep turning around. Then this was the rabbit. Now for the rabbit, this is like a ride-on, so you can just keep riding it on that. So in this, basically, I was thinking that there'll be a tail here, right? The head and the tail has to move. So these are the wheels which will move. Then this, which makes it move, will have another wheel here, which will make the tail move, and there'll be another one which makes the face go up and down like that. So I was thinking of how the mechanism internally would work for a ride-on like this, like a simple ride-on, wherever the kid wants to take it, they can take it. And this was a grasshopper. And for the grasshopper, this is also like a ride-on, which is a free moving thing, so it just takes there. So you can either drag it, or we can give a pedal movement here which takes the bike forward. So you can just go along and this moves. So similarly, like the gorilla was also another idea that I had. So this was also for a ride-on only. So you can have a wheel here, and the ears of the gorilla become the handle for the kid, and the kid can sit here. So it goes like that. So both the hands, like the leg and the hands move. Uh, so then this was another idea that I had for a lizard. So this is a basic crank I made out of a wire. So this is just like and it gives the movement of the lizard. So it just moves, the legs move while this rotates. So this is just like a fun thing, like while one kid is sitting, some other kid can go like that, or even the parents can help, or it's just a fun thing to see how this moves. And this thing is there, the rear of the lizard. So I was thinking that we can have some mechanism which is attached to the legs, and when the legs move, this thing keeps going back and forth, back and forth, back and forth. And this thing here will open the mouth and close the mouth. So while this is rotated, this will open the mouth and close the mouth.
Now, instead of cranking, like this time, we use bullocks or even they are moving around.
Right.
Okay, so just imagine that.
So you want some blank paper?
So this is vertical shaft, and then there are either two or one. These kids move around, okay, and all that action is converted into the action for the central kid who is really
Watching it.
sitting on the.
Okay. So simultaneously, the kid should also be able to see on the other side that it is happening. So, but again, that will become a big installation. So I was thinking on something that is smaller.
Smaller. It should not be larger than this. No? Maybe 8 feet. Okay.
Because we are looking at kids up to 12 years of age, so they can be quite.
12 years ka to, they may not be interested in this. But
So I should limit the age till
up
8.
to 4 or 5 or 6. Yeah. So even parent, like a seesaw is like a 2 people. So this becomes like a 3 people teamwork. Okay. And they will enjoy because others are. But उसमें भी कुछ, it should not become just a mere task for these guys. No? They should
So
be.
because like in the playground, the kids are very energetic, so they want to do everything that they can do, because they're not like getting bored of moving around, running around.
No, that's true. But even that moving round and round should be like a play. No? We play पुलिस एंड चोर और डॉग एंड कैट ना, एक आदमी सेंटर में और 2 किड एंड देन दे ट्राई टू कैच ईच अदर. Okay, something like that. Can you bring in those type of activity even for those kids who are moving and one kid is enjoying this? This is interesting. I like the something happening there.
Yeah, so I used the crank to make this. So it was like just a wire. So I was seeing how the hand movements can happen. So
Yeah.
So I was thinking like I could develop this further as a ride-on toy for the kids.
But how this motion will happen?
So that, like I was thinking, if it is installed in one place in a playground, So the kids would want to sit on it. Like the parents can do this for them, and then simultaneously. So this is just like a ride on, like how this works. Similarly, so this will also kind of move around, and the legs are moving simultaneously. The kid gets the feel of it's riding something like that.
No, your thought process is okay. How it will happen actually? Is it moving
No,
or
it's
it is a
it's still in one
okay.
place. So it's
a-
like an installed thing. Yeah,
okay.
it will be still in one place. If it has to move, then so the wheels come into picture, and when the wheels come into picture, then the fun of the legs
true.
is gone.
Yeah, yeah.
So that is why I was thinking, like, if this is just about the experience of sitting, and then this thing moving.
But that actually that can become a very nice toy. Push along toy.
Yeah.
You can sell the idea
No.
or make one.
Yeah, I can make one.
Yeah, make one.
So one of my ideas so that capturing the moment of caterpillar. So I thought like it will be a ride-on toy, but then it will have like 4 combination of this, and it will be connected to a rotating like hole in the center, and kids can get in and just push it around, so that it will have this up and down movement. So they will get that movement in the circular direction. So the connection will be off centered, and so that it will get that up and down. And another idea was,
No, this is okay. How? What is this for?
so I was thinking like you can have a combination of this like 4 these things, so that it must be in a circular surface platform with that it will go round and round. So at that time 4 people can play in it. So it will be like a team play. So 4 people can sit, 2 people can rotate them.
Okay.
And another idea was like the monkey movement, which actually swings also. At the meantime, it has a semi-rotational movement, so it goes like that. So I thought, why don't I make it a full rotation? But that idea gave me the idea of a swing. So it will have a stand, and this will go like this, so somebody can rotate. But then this will have this small restricted movement. It won't be that fast, but then it will have a small this circular. So,
Yeah, but this is more like an installation, bigger one. Preferably go for the ride-on type. This also is like an
that's
installation.
that is
Yeah.
from a snail that I. It's
No,
like,
one can climb, but
Huh.
no, not really.
Then another one I got was
Because that becomes like a formal
variation.
variation. No? You are actually creating a bigger installation based on the.
Then this one is like a ride-on toy, but then it's inspired from the frog movement. So what we have is similar to like a circular platform and 4 seats, and this is like a rotating disc, and there we have a rod which has a free hinge, so it will enhance that movement. And here we have this somewhat similar to shock absorption kind of thing. So we have a spring inside and a rod here that will push in and out, so that kid can just don't need anyone to help. So one kid can just jump forward, so that it will enhance that movement. So it will just do.
But then you have to really calculate what should be the spring and whether it works, and
This
research. It will require research. No? You have to make the working prototype, crude prototype. It's not just a concept.
But then this works because I see like that Oscar spring that we have, the same somewhat smaller spring can have that.
We want the human body to move. No? Okay, though they are kids, maybe still they are weighing about 20 kilo, 15 to 20 kilo, 30 kilo. वो उसके लिए तो बहुत सारा स्प्रिंग फोर्स लगेगा.
So I thought instead of hopping, then
Yeah.
And this was from the inspiration of
No,
revolving.
no, these are again the bigger installations, no?
These are all installation from spider.
Yeah, these are all,
And these are also.
no, those are,
But then
we
it
have
has
rolled
this.
out, na, that,
Hmm.
yeah.
This is
Yeah.
also somewhat same, but then I don't think this will work.
So, maybe you have to work at this level, how it will really work,
Hmm.
okay?
So this one was inspired by like whenever animal pounces, the prey will try to like move away. So it's like this cranking mechanism. So when pedal you move forward, at the same time this punching bag moves up. So you have to try and reach it and try and hit it. So that's the game part of it. Um, so this one was all the elephants kind of sport in water. So I was thinking like it's gonna be like a garden equipment, which they install it in the back or in the park or something. So instead of a normal sprinkler, like a child can come and pedal on it, and then the jets of water come out. So there can be also like multiple like range of jets coming, and so so basically this when you pedal, this linear motion will turn the thing in an arc. So that was what we're trying to do, and you can have several of these to create jets of water. Um, this one was the rams locking heads with each other. So this is a slotted lever thing. So one side of it be controlled by one end, and the other side be controlled by the other. So they have to coordinate in such a way so that they keep hitting each other and they make a noise. So it moves back and run. So this is inspired by the insects moving in a spiral pattern to escape the predator. So here again when I pedal, this is like a screw and this thing moves around that. So this moves linear. Similar to this is that the screw over there. So this moves in a circular motion, and this is like a playing of dartboards. So you have to play darts, but it's a moving target. It's not a stationary target.
Yeah, but then we are talking about the biomimetics inspiration.
Yes, sir. I
So-
mean, these will have appropriate form of that.
Not the biomimetics, it has so many other interesting features. Huh? Why only form? Form is the simplest. No,
No, I'm not looking at the form. Sir.
no, so I'm saying inspiration from nature, why only the form? Why not the action?
So this is the action of it. Sir.
नहीं किधर है action ये which action is
No, the spiral motion of the insect when it tries to move away from the target. So basically, it's a game of darts, but the animal is moving, and you have to hit the animal.
you are just stretching it too much and
So again, I was looking at
not the installation.
uh,
Not the installation. These are all big things. No? And that's why I said better restrict yourself or ride on.
so this is a ride-on. Basically, it's a slot, and this moves up and down. So it will move up and move out. So I'll be moving, doing this direction when I'm sitting. So and it'll keep moving up. So it'll be like galloping horse when you're moving up and down. So that was the thought. And but basically the idea which I liked was the sprinkler idea, which would
Not really. Whenever you have water and all that, of course, kids love water, okay? But many other issues come into picture. Purity of water. Okay? When kids are playing with the water or those water games and the parents must carry the extra clothing and all those logistic becomes more complex. There are spitting fountains and all those things. Fantastic water sports and water playground equipments are there. Okay? You don't know which fountain is going to spit. Okay, but the kids keep on moving in that area and they get wet and okay. But those abroad you are very sure about the purity and the hygiene of water and all. Not here. Okay, even the water sports that's why water kingdom and there many people don't like to go into those type of public water spaces. Okay. So I will say not really. I'm still not very convinced about your final idea. You have to still work on it. Okay?
First is inspired from monkeys on creepers, how they swing on the creepers. So they hold the creepers and they just swing on this. So I thought of incorporating a merry-go-round and a seesaw together. So there is spring mechanism and there are 5 elements. This can be changed and like there will be this rope all around which will be fixed at these points, and the child can sit or stand on this area, and then when it spins, there will be centrifugal force and they will go out. And
But why it will spin?
how will it spin? Because their legs will reach down and they can push.
No, then there will not be any centrifugal. For centrifugal action, the speed is the important thing. So it's merry-go-round
It's very,
has the motorized thing, no? That there is a power.
some of them we have to operate ourselves only. We sit on the edge and then we move our leg. All of the kids do that and then they speed. Or someone pushes from outside, usually in merry-go-round.
What else?
It might not spin at that high speed, but there's this seesaw mechanism because of the, so it will go like this. Another, this is just a rough idea of a praying mantis inspired swing. So the child can walk or slide on this also, but we will create a swinging action.
Walk means it is a big installation.
It's just one person walkable.
Yeah, but what will be the size? About 4 feet. You will require this much. No?
Other one was this inspired from a dragon. The person can sit and pedal, and this pedaling action will create a crank mechanism which will cause, this is aligned on this axis, and when we move this is the pedal, this neck of the dragon will come forward and backward. So this has to be fixed on this axis. So this will create the action. So whenever they pedal, it will move like this. The head will move like this. And the same pedaling will also cause, like if you put wheels on it, it will move also. So that is the idea of the
So,
dragon.
put the wheels and
Try it out. Yeah. I thought just one.
yeah. Okay. Because to any moving vehicle must have 3 wheels.
Map.
Okay, 2 wheels is a bicycle. Now,
This will need 3 wheels.
yeah.
Center of gravity is not here. Others are, this is a snake inspired multi-user ride where the user can sit here and pedal and it will move just in a particular angle. Like it just swing like
So
this.
fine. So what I will suggest, look at the tricycle. Okay. And can the tricycle wheels be mounted at an angle or eccentric and still it is stable? The movement, jerky movement or the tilting is still within the prescribed limit. Okay. And can these tricycles be connected so they become like a serpent like that, no? Or they are individual also?
Like each unit will be like usable, but how will you give that? Okay, this is another design I was thinking of, this caterpillar where when you pedal it just increases or decreases the height, the cam mechanism, but the issue is it has to be a cam like that, it gives that much of height elevation also. Usually cam doesn't give that much of height elevation.
So you have to work out really, should it be too much, or can the,
It'd be little
if it is like a 4 or 5 kids it's a continuous thing, okay, all are pedaling, but because 3 are pedaling and they are pushing, one kid get lifted, and that maybe in the beginning first kid get lifted, then the second kid, then the third kid.
that
Okay?
wave.
Yeah, wave type of thing, no?
Like-
But then how that pedaling action, okay, is going to result into this lifting action. You require the lifting means you require higher force, right?
You
Anything
have to
to
put the force so that their own weight gets lifted.
yeah,
You have
yeah.
to put a lot
So
of force.
so 3 people. Just imagine that this is 4 or 5 kids are there. Okay, all are pedaling. So sequentially only one get lifted. Possible because all others are doing extra work
To lift that.
to lift that kid. It's possible. Look at the mechanism. That will be very interesting.
It is like those automator machines where you pedal and there's this
Yeah.
wave which continuously repeats. Something like that. Other was this, it is bit of an installation type, but the child can like climb up and there's a trampoline.
No installation.
Yeah. It's just one of
No,
the
that's right.
ideas.
That's fine. So I will suggest work on these 4 or 5 people working as a team. Okay?
That will also become quite big.
But these are like a, yeah, it will be little bigger thing. It is moving. Okay? I was talking about the tricycle, no? The tricycle which are connected. Okay? It's okay. It will be about 6 feet or 8 feet long too.
Okay, so I'll focus on that.
Yeah.
So this is the bicycle that I have designed for riding in the sand pit. So this is the free wheel, and this will be having that chain and other system, and the child will be sitting over here. So it doesn't have like any other mechanism.
It's
Very
okay.
simple. The second is this chair thing. Actually, the mechanism is not working, but the idea was it will be combined like this, and once a child is sitting on this like this, it will automatically come like this. So the movement will be like this. So other child who is sitting over here, so they will be using it like that.
So seesaw in another.
Yeah, seesaw and like where child can lie down and sit on
So
a chair.
how it will work?
So I'm planning to use a gear system over here, where like scissor we have. In the scissor also we have this opposite movement. So regarding that I thought of, but that wasn't working. So now I'm
See, in seesaw, advantage is when seesaw is there, heavy weight
yes sir.
and lighter.
Lighter.
Lighter sits further down. Okay, so he or she gets the L1 into that weight, and the heavier one sits nearby. So the torques are to be equal.
Equalized.
Okay, how the torques will be made equal?
Okay. I did not.
It's an interesting concept. Okay, how it will work? Look at that. Can kid instead of just kids sitting in a one particular this thing, seat, can the seating be at a different level?
Okay.
Means these are not complete seats, but just imagine that there are rods. Okay, we sit even on the rods, right?
Yes, sir.
Okay, so the kid which is heavier, he sits nearby. Okay, so the rotation is equivalent to that L1 W1. Okay, and this other one. So actually, your seesaw, you don't require this.
Okay.
Seesaw is just imagine
Just
that. At the moment, seesaw is straight, but you are talking about the seesaw which is like this. Okay, and this is the pivot almost on the ground. Kid can sit at a various level, and kid, the heavier one will sit here, the lighter one will sit there.
no, no. It's just for one kid and this is for the other kid.
Yeah, that also is possible, or I'm saying this is
Yes, yes.
one
that is-
direction. Okay,
Yes, sir.
so how this will happen, you have to think about the mechanism.
Yes, sir. I will be working on this.
Yeah, okay.
And so the third one was it's inspired from the motion of the caterpillar. So this was actually it's not working, but these are four wheels will be working together like this. So the child will be sitting over here, and there will be a paddling system which will be guiding these two. So the child motion will be like this.
Look at how it will happen.
Yes, sir.
The pedaling, how
How the pedal is going to.
how power is to be transferred, no?
Yes, sir. Yeah, that is what I have to still work on.
You have to figure out how the power will be transferred.
Yes, sir. So I will
Yeah.
work on this.
Okay. Yeah.
This is the one
Okay.
of the writing chart, right? So basically, imagination plays a very big role, and making their bicycle to mimic a horse will actually add on to their gameplay in many ways, and because horses are also a part of our culture. So this is one. Rest of them are
No, installation we said na, that those are big, one has to really experiment, and maybe you can take them as a P2, P3 the next year.
Sir, but the thing is, if we don't work on this situation, the other option is a movable object.
Yeah.
So, but then,
No, it can be even the two, like I said, can there be a new seesaw? Okay, seesaw is like a team, two people are working. So, can there be something more happening to seesaw? Or even the swing, at the moment, swing is the individual exercise.
yeah,
Okay, but swing is also like a big installation. Seesaw is that way smaller installation. But a ride on toy, which is like at the moment tricycle is just a tricycle. Nothing is happening more. And can we add something so that something more happens with the, not just a shape,
not shape.
not just a shape. Okay, because all this, if you see the tricycle, we have horse, we have panda, we have
Yeah.
everything.
Huh.
Okay,
Yeah.
but those are shapes.
Huh.
I don't want just a inspiration from nature for a shape. Designing form is very easy, but we said that the mechanism, something interesting happening. Okay, either a dragonfly or an inchworm or something which is interesting to look at, which is interesting to feel at?
So this is one idea which I just thought of because I was also listening to all the comments you were giving.
Yeah.
So this is a stingray, which is a stationary stingray. It can move also, not decided yet. But then all the flaps of the stingray, it moves in that wavy manner. So if somehow I can incorporate that in a pedal mechanism, so whenever the kid pedals, so it forms this wavy pattern as it goes.
Yeah.
So
But all fish, okay, the stingray, their this thing is quite interesting. Okay, but why not a linear fish itself? Can my tricycle, okay, instead of moving straight, can it move like this? And it has, I'm saying like a fish, no, वो जो
छोटा सा toy.
छोटा जो fish है, just imagine that it is ride on toy, okay, it is moving like this, and something more is happening. Possible, eh?
Possible.
Just work on that one.
Okay. Yes.
So I changed the idea of that visual thing which I had thought of last time, like 10 ideas on that. So now I've thought something that gives motion to it. So there will be a hand and then this will have a wheel inside it, which will be hidden by the leg, but then it will be like slightly more, it will be seen. And the same wheels will be like connected with a cylindrical thing with a slit which will have the tail connected to it. So when it moves, the tail is going to move at the back, is what I've thought. And also like this won't be like a 2D thing. It will have a form of this.
Don't make the wooden toy, okay? If you create a form on a wood, it's most expensive. Because you will require a craftsman to carve it out, right? Or machine it out. Machining is always costly. And lot of wood is wasted. All wooden toys, I will suggest, make from the MDF more plainer thing, 2 planks or 4 planks, the various levels, okay, like that chitty and no, that should be the approach. Okay, so you can make a hen, you can make whatever you want, okay, but the construction should not be like a block, like a form which is solid form. Thermocol is so easy to sand it out and all that. Wood is not. And it's expensive. Okay, so chitty and that should be the inspiration. The construction should be from MDF or 2 planks, 4 planks and okay.
Then I thought of a frog which will have spring at both the position, like at the legs and over here. So it is like simply you press it and it bounces and it
But
moves.
we are saying push on toy. This. Okay. Whatever frog jumping action or whatever, it should happen when you push this toy in front of you. You can, and the construction is like that planks. Okay. So not the form. You have drawn the formal thing is quite good. Now you have improved your sketching a lot. Okay. But I don't want the form. Like a big solid shape. Because it is expensive. The construction might use MDF, you can do the laser cutting, you can do the freight saw cutting. Okay. So all this, now you convert it into the
2D which
mechanism which is built, I explained on the board and okay, the chitty or how it will happen and I'm pushing it. So if it is a frog, what is the interesting characteristic of frog and how it jumps. Okay? Or how am I mimicking the frog walking in front of me? Which one you will like to work on?
So I had thought of this because this would have that movement.
No, that is okay. One, maybe one antenna, one hair can be mounted on a spring. But more than that.
Yeah. Okay, this movement.
Okay? So you have developed the form, not the mechanism. I said the quick prototypes where the mechanism is involved. I want you to work on the mechanism. Okay?